Okay. So it started with an LP and continuous development got converted as an now the new techniques or the technology you can say the Gen AI. So usually why we say it as a Gen AI. So the reason for the Gen AI is it has the capability to generate something. But till now in NLP, whatever work we were doing, it doesn't had capacity to generate. Okay. So that's why there's algorithms, some algorithms discovered which can generate the new things, completely new things, whatever the data has not seen while training or the model has not seen while training, and they generated a completely new thing. Okay, and they are able to think like a human brain. So like if A likes C and B also likes C, so they can able to understand whether A can like B or not, like that. Okay, so they are able to match these kinds of decisions, reasoning, chain of thoughts, that if this is true, this is true, then what it would be for this. So like that. So this is how the generative AI came in scenario. And then in this generative AI, when I'm saying how those algorithms actually got developed, so there is something called RNN, recurrent neural network. Then it came LSTM, long short term memory, and then GRU, gated recurrent unit. Okay, then it came transformers, and then came attention. So these five techniques, if we know, then we can able to understand the any kind of algorithm which is nowadays coming in a Gen AI. So if you'll go on a basic, this is recurrent neural network. Recurrent neural network is RNN. LSTM is long short term. GRU is gated recurrent unit. This is transformers, and this is called attention. These all are deep learning algorithm, neural network. Yes, these all five are the neural networks. These all five are the neural networks. Okay. If we have a study, doesn't mean these were not existing, right? Mhm. So this GRU transformers and attentions are also there. These all are the neural network based. Okay, these all has the neural network. So this all actually overcomes one of the limitations of the prior algorithms. Like LSTM has overcome some limitations of the RNN. GRU had overcome the LSTM issue. Transformer has overcome the GRU issues or LSTM issues and LSTM issues, and the Tensor has overcome this transformer issue. So this is all. And nowadays, whatever, yes. Hmm. I'm coming. So whatever the now GNAI algorithms are coming. So let me tell you some very basics. The most popular or most downloaded on the Hugging Face is Flan T5. Flan T5. Okay. This algorithm or this model was trained by or developed by Google. Okay. So this is one of the very popular on the lightweighted also we can say. So there are three versions of this. One is called small, one is called base, and one is called large. Okay. So Flan T5 small, base, and large. I'll show that each and everything how we can use that, how we can even tune that for our task. So this is algorithm. Now, so Flan T5 is one of the now Microsoft has recently launched Phi 2. So this is also one of the I mean the generative algorithm, generative AI model like Zephyr, ZDPHYR. This is one of the famous. Then something called Mistral. Okay, Mistral is there. Another is called mixtural. So there are lot many. If you'll just go on Hugging Face website, you will find lot many models. So our first agenda is to understand these all algorithms. Okay. So what I will do, in spite of going with the RNN, I will start with the LSTM. If you'll understand LSTM, in the mid of that you will understand the RNN, because RNN had some issues. Those I will cover in that LSTM, because you can understand RNN. One part of the LSTM is RNN. Okay. So once I will completely explain the LSTM, in that the one part will be the RNN. I will show the image of both, and while explaining, you will understand that this RNN is the smaller part and the LSTM. Yes. Hmm. First of all, whatever you are seeing this, these all are just a structure. Okay. These are a structure. It doesn't have any what I can say, weights, or the storage kind of 5 GB, 10 GB, 1 GB. Like it's just a structure. It is just a structure in which you have to feed the data and you have to train that structure. Okay. So let us suppose, if I'll give an, if this is, let's suppose some LSTM model is there. Let's suppose this is LSTM model is there, architecture. Now this one you can make it by your own, or you can use any framework from Google, which is TensorFlow, or from the PyTorch, and you can build this structure. Yes, this is completely equation. These all are equations, nothing else. That nothing else. Yeah, so I'll tell what exactly. So if suppose, just understand this one LSTM structure had 500 parameters, let's assume. So if I will just stack 10 LSTMs, so it will be 5,000 parameters. Now if I will train it for some specific data, there will be around 5,000 weights are there. Now if you will utilize these trained weights, that is called transfer learning, means those weights were trained on some specific task, and that I'm using. Now you will feed your own task and it will give the output. This is, so till now, if you haven't trained, so these are the structure. This doesn't have any like you have to download that, or it's not like that. You do not have to download the RNN, LSTM, GRU. These are just an equation. The way they wrote the equation, so that you can utilize that for your training. So we will start with the very basics. When I'm talking about the implementation side, very basics, like as in NLP, the pipeline, that how to handle the text, is the first is to pre-processing of text. So when I'm saying a pre-processing, how you can first understand the text. Understand the text means, uh, let's understand, there are two people, and one has the text data from the finance side, and one has the text data from the retail side or from the telecom side. So it can happen, the word which is important in the finance side, that might not be important for the telecom side, or the word which is important for the telecom not important for the finance, vice versa. So you must have to understand the entire understanding. And please mute yourself, otherwise it isn't recording now. Your voice will come, someone is speaking in the back end. So uh, so that's what you need to understand the text very carefully. And this is not for the text, for any kind of problem in machine learning or the AI. Once you got the data, you need to understand domain wise as well, that what is the importance of any features or any record. Okay. And then there are a lot many steps like stemming, lemmatization, when we have to do, what is the use of that, what is vectorization, what is embedding, what is difference between how the one hot we can play, or what different kinds of embeddings are there, what are some pre-trained embeddings, what is something called OOB, out of vocabulary issue, how to handle that, how to custom train a model, how to train a model for a custom training. Those all things we will understand it one by one. Okay, so we'll go in that manner, that then only the figure for this GNAI will get clear. So if you will understand in that manner, that from the first or the second day we will start the GNAI project, in that case what will happen, only I will understand, you guys will not understand, and you will not be able to use in your careers, like in either your resume or any of the projects. You cannot be implement, maybe you can memorize one of the project, but you cannot able to implement that, because there are lot many parameters, that what is encoders and what is decoders. Okay, in GNAI models, some models are only encoder model, some models are only decoder model. So we need to understand why they build some models are only encoder, some models are only decoder. They build some models are with combined of encoder and decoder. So why they build that? What was the reason of that? Why they are doing such thing? So these all things we need to understand with hierarchy step by step, and those all answers are within this architecture in RNN, LSTM, GRU, transformer, tensor. And I'm telling you, once this all concept will be crystal clear for you guys, then you will understand the GNI part in a very, very quickly. Okay, and it can solve your lot many problems. Okay, so understanding LSTM, GRU, and transformer attentions are very important. Now, hope it is clear till here. Okay, now, so yeah, okay, I'm coming on that. Mhm. Mhm. Yes. So whatever the GNAI models are there, no, those follow these two structures, this transformer and a tensor. Okay, and within that again there will be an LSTM or the GRU. So these all are the combined. Okay. Now, one second. Yeah, what was the question? Hello. Of any generative AI models. Okay. These are under a transformer at a tensor. This will come. Okay. Now, let me tell you with the hierarchy on a very high level. We will go on a depth as well. This RNN, LSTM, GRU, transformers, and then attention. This is. So, what was the issue with RNN? So, this was actually the major breakthrough to understanding the context of the text, that what actually the information in a text. But the problem with the RNN was, right now I will not answer the technical terms, that what in the technical it was happening, but for to understanding one who doesn't know RNN, I'm just assuming it was not able to understand the longer context sentence. Let's suppose we have written a three-line sentence and the last word is somehow related to the second word, then it will not able to establish the connection or the context between that first and the second and the second and the last word of that sentence. There it was getting failed. Okay. So this problem was solved by the LSTM by providing the memory cell in the LSTM. Memory cell in the LSTM. This problem was solved. But what happened? This one became too slow. First thing. And the second issue was with that it was able to handle this kind of this length of context. But if it is a little bit more longer, there it was getting failed. So this was the two issues. Now what they did in GRU, they reduce some of the memory cell and make it faster. So GRU are bit faster than the LSTM, but their performance are not that much good as the LSTM. But it is little bit lesser than that, not a significant. Okay, so that's why there are a lot many people they use the GRU as well. Now the transformer. So what they did, see, still this problem was continuous. So they used here encoder and decoder based architecture. So to understand the context, they have other structure, and to again answer it or to generate it, they have the other structure. So this one actually give the major breakthrough to understand more longer context sentences. But what issue happened in this architecture actually in transformers? Let us assume you have a word like Apple is going to invest 3 trillion in India, or someone has written I am going to buy a apple. I am going out to buy apple. So this was not able to understand the context of both the apple in most of the scenarios. But because here the apple means something else and here the apple means something else. So it was not able to. So that problem was solved by the attention. So they have used one of the techniques we will understand, KQV, key query and the value vector. They utilize this concept and they were able to solve that. And we will see it with the example, the vector. So for these all, what you guys need to understand vector addition and multiplication. It should be clear. Okay. Second, there are few mathematical concept you need to understand. What is sigmoid? What is tan h at least? And the softmax. These three concepts you must be clear. Okay. Okay. Then a little bit basics of the probability. Basics of the probability. So if almost if these three things are that clear, you will able tan h tan h. Sure. No worries. Okay. So these all things we need to understand it clearly. Okay. Then only we will able to understand when I'll try to explain that how exactly the things work. So before the classes start, so you guys have joined. I was building the architecture of the LSTM to make you understand, but one guy didn't join. Maybe because of the Sunday or Saturday, or it is the first class. That's why. So for tomorrow he'll join and we will start going in a depth in LSTM. And see, LSTM is, I would rate it as an multiple star. Okay, this is very very important, very very important. If you are seeing yourself career in LP field, you must have to be clearly understand the working of the LSTM. Okay, this is very important, and I will try to cover each and every blocks very carefully. Okay, so this is you understand the this is pipeline, that how this discovery and the progress happen. Okay, and now after this and these all things, let me tell you that what how Gen AI models and what part I will cover. The first, how to convert text to SQL task. Just provide an input to your model, it will convert into the SQL. How to build a Q&A, question answering bot. Okay, with UI like a chat GPT, like a bard, we will make that. How to create a chatbot, you can say, with multiple PDFs, multiple PDF. Okay, if you have a 10 PDFs and you want to extract the information and answers for that, how you can do that. How to custom train your Gen AI model for your task. What is the way? So for the training, there is something called uh, in PEFT, parameter efficient fine tuning, something called LoRa, QLoRa, and something called PPO. Okay, and then something called DPO. Okay, so these are parameter efficient fine tuning. Parameter efficient fine tuning. So this is a technique by which we train the custom train the model. Okay, so this one, then after you guys will be able to understand, and we will see that how we can use Hugging Face. Okay, so majorly I will cover with the Hugging Face. Some I will use the Google Palm API, also the Google Gemini model, how we can use the Gemini model. Okay, to create our user, because Gemini, yes, by the Google. And then after some frameworks like LangChain. It's a Gen AI model, so that's what it is. And Hugging Face is a repository in which there are multiple models are there. So I will, that's why I wrote that the maximum model which I will show and use is from the Hugging Face, because those are open source, and Gemini is also open source, so I'll use the Gemini as well. LangChain and Llama Index. These two are the framework by which these are the, understand, this is a wrapper over the large language models or the Gen AI models. LLM models, people say it's an LLM. Gen AI models, people say it is an LLM, large language model, because those models are trained on the very huge data. Okay, so that's why they were saying it's a large language models. Okay, LangChain is a framework in the Llama Index framework, that if you want to provide a memory to the your language model, we can provide. If you want to provide some chains, sequential information to your language model, you can provide it using the LangChain. Okay, so these things can be done by using the LangChain, and we'll see those all things. Hmm. PFT, see, training a Gen AI model, there are two, three ways. Okay, the one is called SFT. Okay, One is called RLHF. Okay. And one is called, within RLHF, there is something called DPO and PPO. Okay. So SFT we will use, and then we will use DPO or PPO both. These two. Okay. Yes, within a reinforcement, these are the two techniques for that. Okay. Mm. So we'll use that. Yes, but I haven't trained or have the depth understanding on the multi models. But yes, we can do it while explaining these, or I mean, once I will definitely while covering these parts, if I would get any concrete information or knowledge about the multi model, definitely I will try to explain. Sure. Yes. 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 Definitely. Definitely. And then after, which is called vector DB, vector database. So there are multiple. One is called Chroma, one is Pinecone, uh, and then after FAIS, which is by the Facebook. Okay, so there are lot many, but majorly I will use this. Okay, this is more convenient for me. FAIS. Okay, so so vector DB, how it solves the actually contextual issue with that. So what contextual context length of the GenAI models, we will see that. Okay. Okay. So probably this would be we will cover it from, but tomorrow we will dedicatedly start with the LSTM. Okay, without delaying anything. By the end of the first minute of the tomorrow session, uh, we will start with the LSTM. Once we'll join, and after that, the next minute, we will start that how exactly the LSTM works. But I would request you guys to just try to understand by your own, at least vector addition and the multiplication. At least that how it works, and multiplication how. And if possible, if you times allow, and if you get interested for the sigmoid 10H and the softmax, that how it works. Okay. Because once you will understand this, tomorrow I'll just give a little bit glimpse, you will catch that. Okay. Usually you do not have to install right now anything. So whatever the training and anything, everything we will use the Google Colab. Okay, this is world most efficient and the easy to use. Okay, we do not have to do anything in that. Okay, so nothing to worry for that. Everything can run in the Google Colab. So I think okay. Otherwise, I was prepared to explain the LSTM. But okay, no worries. Tomorrow we'll start, and because LSTM will take time, so 1 or 1.5 hour it will take tomorrow. Okay, for the LSTM. Okay, I'll try to send something which can have the information on the vector addition multiplication, this sigmoid 10H and the softmax. Okay, I'll try. Okay, sure. Same time 10:30, and we'll go 11:45 till.